going to be the first part of this assignment, or actually will be the whole assignment that you have today on the null hypothesis and alternative. But in my other classes, we actually got to do a full phantom model, and we have not got to, we won't be able to today. But that's okay. That's not part of actually the homework part, so it actually worked out okay that I could split this lesson in 2 parts. So, first things first. We are starting today. Yes.
The panic model. What does panic stand for? It's not like an acronym.
Yes, it is.
What's the A stand for?
Assumptions and conditions. The name of the test or interval. Interval. Conclusion. Pretty much during the lesson, whatever, 19.2, part 2. Okay. All right. So, here we're going to be talking about a hypothesis test. This is like the whole reason that we take Introduction to Statistics, or this class, is because you want to get to this point where you can run a hypothesis test. Every single thing that runs off of statistics is primarily based off of a test, hypothesis test. Okay, so in short, here's what's going to happen. Somebody's going to claim something for a parameter. They may claim, the average miles per gallon of this new model of car or whatever. And you are then going to collect a sample, and from that sample, you're going to decide if the claim that the person is saying is plausible. So you are going to end up comparing your sample to the claim. And what we will then have is we'll have evidence to either reject the claim. These are the 2 choices that we'll end up having, is we can reject the claim because we have a sample that is far enough away from the claim. There's no way I would have gotten that if the claim is true. We will either reject the claim, or we will not have evidence to reject the claim. And we call that, we fail to reject the claim. We never, ever, ever are going to be able to say the claim is true, or, I accept the claim as fact. Okay, no. We just end up either having evidence to reject it or not having evidence to reject it. All right. But the first thing that we need to do is understand the language of setting up a hypothesis statement. So, we actually are going to learn this new model called a phantoms model tomorrow. But before we do that and use this template on the phantoms model, we are going to do these, understand how to make an alternative and a null hypothesis. So will you turn to this page in your notes? I think it's the second to last page. Okay, so first off, the null hypothesis is your claim. So the claim that is made is called a null hypothesis. It is always an equal to statement. Somebody claims that the proportion of the jury, or proportion of the county that's Hispanic is 19%, then you are saying that proportion equals 19%. That's what the null hypothesis will be. It is also notated as an H with a little O. That's the null hypothesis. Okay. Now, if you end up rejecting that claim, then you have some options. You would go then for the alternative. The alternative hypothesis, you can write with a capital letter or a little case. I usually write a lowercase. The alternative is, you can say, no, what you say is not true. The real parameter is actually less than what you are saying. Or you might be able to say, no, I reject what you say. The real answer is actually greater than what you claim. Or maybe I don't even know if it's falling less than or greater than. Maybe I just know these ball bearings and this mechanism are not working. I don't know if they're too small or they're too big, they are just not working, then I have found evidence that they are not equal to the size that you say you are manufacturing. Okay, so these are options for your alternative, but the null hypothesis is always an equal to statement. So, what happens is our null hypothesis is our claim. So in essence, our null hypothesis is going here. And if we end up getting a sample in this section here or this section here, then those are called rejection regions. So this part and this part are the rejection regions. If we end up with a sample in those tails, then that's far enough away to reject the claim. This is a not equal to situation because I don't know if it's really, really low or if the problem is really, really high. I just know that it's not equal to, it's far enough away in one of these directions that I'm going to reject the claim. This, on the other hand, would be the alternative case when it's what? This tail is showing I'm only interested in if it is. This one's going to be less than. So the rejection region, what happens is I get a sample down here that is so low, there is no way your claim can be true. It must really be less than what you claim it to be. All right, so this is your rejection region here. Okay, so we're going to now practice writing these parameters, which is what the problem's about, and a null and alternative hypothesis. And that's all. We're not going to go into the whole Phantom's model. So here we go. Number 1. A car dealer advertises that its new subcompact model gets 47 miles per gallon. Well, you're going to assume that the dealer's not going to underrate the car. You know, it's not going to be a 50 mile per gallon car and he's just going to say 47. Okay. We're worried with him overrating the car, overstating what the miles per gallon is. And so you are suspicious that he is overstating the miles per gallon. So first question, is this problem about a proportion for the subcompact cars or a mean for the subcompact cars? Okay, it is about the mean. So you write a mu. This is what we are talking about for this problem. And what is it about? The average miles per gallon for the new subcompact model. Okay, so that is what we are going to be making a statement about, is this claim. This parameter is always the thing that is what this is about. The item with the treatment. The item that we are checking out. All right. The null hypothesis is going to be that the average is 47 miles per gallon because that's what the car dealer is claiming. Don't just put the null hypothesis equals 47 miles per gallon. I get some people leaving out this mu equals part. Okay, so don't leave that out. So what's the alternative if I think that he's overstating the miles per gallon? The miles per gallon are actually less than. Okay, so that's what I'm going to be checking for. I'm thinking it's actually less than 47 miles per gallon. Okay, that's the start of the thinking process. Then you go collect a sample, and after you collect a sample, you see if it's far enough away from the claim that it is in the rejection region, and then we can reject his claim and say, oh, no, 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 it's actually less than 47 miles per gallon. We will never have the power to say what it's now changed to. We can't say it's actually 43 miles per gallon. No. We only say it is less than the claim or greater than or not equal to. Okay, let's do number 3 here. Number 3 says that a company manufactures ball bearings for the precision machines, and the average diameter of a certain type of ball bearing should be 6 millimeters. Is the average diameter correct? Okay. So first, proportion or mean problem. Okay, good. we are going to be making a claim about the average of what? Okay, good. Average diameter of this manufacturer's ball bearings. Now, and then I'm going to probably put millimeters here. Okay, so what would my null hypothesis be? That the average, what, equals 6 millimeters. Good. Okay, the alternative, however, is going to be what? Does not equal. I don't know enough about what's going on to know if it's greater than, or it's way big or way small. I just know something's not working right. So I know that the average they're putting out is not equal to 6 millimeters. So I'm going to check both directions, way high and way low. All right, very good. Now, there's one more that I want to do with you, and then I might have you practice a couple because we'll have time for that, so that's good. And that is this number 4. Obviously, you can see from the first statement that since we are now talking about this information in 2006, which is about 16.1% of all heart attack patients died from any cause in the first 30 days after being admitted to the hospital. So this is then, of course, a what kind of problem? Proportion problem now. So there has been recent national efforts since 2006 to improve the quality of the heart attack care at the hospitals. So have those efforts improved the heart attack death rate for any cause in the first 30 days after being admitted to the hospital? Okay. So our p-value, or our proportion name, is going to be the proportion. Our parameter is the proportion of what? Okay. All heart attack patients that what? Okay. This is where this is a new thing that I actually know is a big deal. You cannot write this parameter in past tense. Heard perished? You see here it talks about in 2006, this is the proportion that died. But we're now making a decision about current conditions. So this is about current conditions. Do not use past tense. So this is about the proportion of all heart attack patients that die, current tense, not past tense. Very important. Past, I can actually compute. I have the data. I can figure it out. There's no disputing that. It has happened. I am talking about current situation. That die from any cause in the first 30 days after being admitted to the hospital. Okay. So your null then is going to be that what? P equals 16.1%. And if they were hoping to improve the conditions and the quality of heart attack care at the hospital, then what are they hoping has happened? P is now less than 16.1%. So you then go take a sample, see if that's far enough away from 16.1 to reject 16.1. Okay. So that's what's happening. So when you look at your homework, there's actually a few things I want to talk to you about on it. So pull this up. Number 1, I drew pictures, but you don't have to. please make sure you are specific. For example, with number 2, this one is about the average miles per gallon for a car with the carburetor. It is about the group that has the treatment occurring. That's what you were trying to talk about. Just like up here at number 5, this is about the average birth weight of babies where the mothers have taken the vitamin pills. So the group is about the treatment group. Now, last thing, this says at least, while you're packing up, I'll still talk. This says the bottle has at least 67.6 ounces, which implies equal to or greater. But look, your null is still just equal to. Even though it sounds like you should say equal to or greater, the null is always equal to. All right, goodbye.